So before we move on to learning new material, I really want to give you a little bit more time to practice doing some of these proofs using the inference rules and the derived rules. And so what we're going to do in this relatively short lecture, I hope, is I'm just going to do a few more examples and talk a little bit about how I think about these things, how I think these through. So before you continue watching this any further, please make sure you have a copy of these proof rules and also of the derived proof rules all printed out. It's on one sheet if you just download it from the web. So, I titled the first slide Using Your Wits, to kind of making fun of the book. The book's always talking about using your wits to do things, right? Which really means kind of doing it by the seat of your pants, right? Just kind of figuring it out. You got to, and unfortunately with proofs, that's what you got to do. You just got to kind of try and figure it out. And really my goal with this set of slides is to help you get by with fewer hints than before, right? I'm in the first set of homework that I gave you a lot of hints as to, oh, you want to do this subproof, oh, you want to do this. And now I'm going to try and transition you. I'm going to give you a little bit more practice with these problems and get you to do them with fewer hints. So as you're doing any proof, here's my kind of guidelines to think about. Make sure you keep your ultimate goal in mind. What is the final thing I'm trying to get to? All the time, keep looking at those inference rules, the proof rules, and try and say, what rules could I use now? Right? And then, of course, in the back of your head, if you ever need to prove that X implies Y is a tautology, you always want to think about the conditional proof rule. And finally, most of us don't want to use subproofs. If you can get away without using a subproof, that's great. But when all else fails, consider, and I just kind of called it creating what you need in your subproof using CP or IP. So let's just go through a few examples. Here's the first. Start with this as your premise and derive that. Of course, as soon as you're given something like this, from this derive that, the first line in your proof is going to be whatever it is you're starting with, right? That's your premise. And as we've seen before, your book will sometimes kind of skip a step and get rid of that and just have two premises here, but I don't like that. We're just going to have one premise, whatever it tells us we're starting with, and then we'll use the simplification rule as necessary to get to the sub pieces of that. But when you see something like this, from this derive this, you automatically know the first line of your proof is going to be that premise, and the last line of your proof, you may not know the line number, but you know that we're going to be saying, whatever it is we're trying to derive. And again, you really, for this one slide, I kind of pasted in a tiny version of these proof rules, the inference rules that we have, but you really need this on a big sheet next to you. So hopefully you've got all this ready and on a big sheet. So let's keep moving. So the first couple of steps in any proof, if you have a premise that has an and in there, is to do some simplification and get the individual pieces out. So, at some level on these proofs, even though you may not get full credit on your proofs, you can still get partial credit if you do just the first few steps, the last step where you write your, the last step, whatever it's going to be, and you write QED at the end, right? So let's keep going. I know for sure I may not need it, but given that I was given this as a problem, as an assignment to prove, I probably do need each of the individual pieces of this premise. So let's just always get into the habit that the first thing we're going to do is we're going to take this out from the premise. So that's based on line 1 and simplification. And similarly, we'll get out the A, right? Based on line 1 and simplification. And now, where are we going? We're trying to get to C, right? And if we look at the problem, we can see that we have this implication thing, and modus ponens is our friend. whenever we see implication, you want to first think, can I use modus ponens to get there, right? Because if I have this first piece, the A or B, I can use modus ponens to give me the C and I'm done. Now I have A. What I really need is A or B, so you want to kind of look at your rules. What the heck do I need? I need A or B. And I have A. Well, look at that. I have the addition rule, right? Admittedly, I gave you a very easy one for the first one, but let's see. So I can conclude A or B based on line 3 and addition, right? And so then this will actually be line, why don't I cross it out and write it up higher? Line 5, I can now conclude C, and I'm concluding C based on, let's see, what have I got? Lines 2 and line 4 and modus ponens, and then make sure you put your QED at the end. So, you know, this one wasn't too bad, no subproofs. It just kind of flowed. I know that it is just really hard to do these unless you practice, and just try. So just keep trying. Here's something else. Modus tollens is one of our additional derived rules. And what I want to do is prove modus tollens using just the basic proof rules, right? The plain old inference rules. So what am I asking you to do when I ask you to prove this? Well, I'm saying, given this premise, derive not A. So again, the question is, given this premise, derive this, right? And so we know that the first line of our proof is going to be a premise, and the last line is the thing we're trying to derive, right? And so now we just got to kind of fill in the middle. And of course, we have an and in here in my premise, so I know I'm going to use simplification. I know I've got A implies B, and that is just based on line 1 and simplification. I know I've got plain old not B based on line 1 and simplification. Okay, and now it gets tricky, right? Because now I say, where am I? Where am I going? I'm trying to get to not A, and I don't see, you know, an obvious modus ponens way to get there, right? Modus ponens is often the way we get places without needing subproofs. Sometimes we use modus ponens and subproofs too, but and what do I need? I need not A. I just don't see, I don't see a way to use conditional proof to get to not A. I don't see a way to use modus ponens. I look at my proof rules. I don't really see where I'm going. And so, excuse me, what I think is, well, I'm kind of stuck unless maybe I try and do a subproof, and conditional proof not going to get me there. I don't see how conditional proof is going to get me there. So I guess I need to try and use indirect proof, this IP, right? Proof by contradiction, or yeah, proof by contradiction, right? I'm going to assume the opposite of what I want to prove, right? So why don't we just think about how would that work? And what I'm going to do, just to make it really clear in the slides, is I'm changing colors for my subproof. Now, it may turn out that we do the subproof and it just breaks, it doesn't work, but I don't think that's going to happen. But so I am color coding this. I'm going to change color with my subproof. I'm also going to do the indentation, which is the important thing, which is showing you that I'm doing the subproof. Make sure when you're doing your homework, you do the indentation. Make sure when you take tests, you do the indentation. That's the most important part. But so if I'm going to use this indirect proof, I have to assume the opposite of this, right? Assume not of this, right? So I'm going to assume not A, right? And I'm going to say this is a new premise, right? It's a new assumption. And your book will write something like, for not A, right? To show, haha, you know, let me tell you behind the scenes, this is what I'm trying to do, okay? If I have not A as a premise, well, double nots aren't going to get me very far. So we can have just plain old A by the double negation rule. So that'll be line 4. and double negation. And now let's see, where are we? Aha, this is looking better, isn't it? Because of course in the back of your head you always have, can I do modus ponens yet? Can I do modus ponens yet? If you have any implication, and we have this implication up there. So yay, finally I can do my modus ponens. So I have A implies B, and I have plain old A, which means I can conclude B based on line 2 and 5 and modus ponens. But now, check it out. Remember, if you're doing proof by contradiction, right, you're trying to get this IP, then you're trying to derive false, which means you need A and not A, or in this case, B and not B. So we can now say we have false, right? And how did we get false? We got false based on line 3 and line 6 and the contradiction rule, right? And terrifyingly conveniently, that makes this line 8, right? We can conclude not A based on lines 4 through 7. Notice it's not 4 comma, but 4 through 7, right? And our indirect proof. And we can say QED. So there you go. Let's do another example. Let's prove another one of those derived rules. This time we're going to prove hypothetical syllogism, right? Again, we've got a premise and what we're trying to get to. So we have the outline of our proof. We have our premise line already, and we have what we're trying to get to at the bottom. And since our premise has an and in it, we can immediately say, well, even before we think about anything, I've got A implies B. That is from line 1 and simplification. I've got B implies C. That is from line 1 and simplification. And now we can actually look at this and see, where am I trying to get to? I'm trying to get to A implies C, okay? And, you know, as soon as you see that implication thing, you think, if I get stuck, I might be able to use conditional proof, right? And if I look up above at lines 2 and 3, I kind of already feel stuck, right? I'm just not sure where to go from here. And so I'm thinking maybe let's assume A and see if from A we can derive C in this case, which would give us that conditional proof thing. So I'm going to do this, and again, I'm changing color so that you can, so I make it really clear what's my subproof, but I am changing color and indenting because really we don't use color in our proofs except when we are watching Dr. K's weird videos, right? But in general, no color in proofs. I'm just doing this to emphasize which piece is the subproof. Okay? So I could get A implies C if I have A as a premise and then I derive C. So let's have A be our premise. And again, your book would write something like, for A implies C, to say this is where I'm going with this. Don't be surprised when I get there. And if I have A, all of a sudden, modus ponens just opens up, right? Because if you look at line 2, got this A implies B, I've got A. That's wonderful. So I could say B based on lines 2 and 4 and my favorite modus ponens. But now that I've got B, I can do another modus ponens, right? I can get to C based on lines, what do we have? B implies C, 3 and 5, and modus ponens, and magic. Look, what was I trying to do? I'm trying to get A implies C. From A, I derived C, therefore, let's get rid of that. I could call this line 7, and outdent, we're back into our main proof again. And I can say I get A implies C based on lines 4 through 6. It's not 4 comma 6. It's not just 5 and 6. It's not whatever. It's 4 through 6. We're discharging. And my conditional proof, QED. Okay, a few more things to prove. This says prove that something is a tautology. And let me just make myself a little bit more space here. Oops, there we go. But look, I'm proving that something is a tautology and that something has my magic implications in it, right? So I'm going to assume A is a premise. I'm going to conclude all this stuff, hopefully, and use CP to get me there. So let's get started. I know for sure that my premise is going to be A. And I'm not going to write it down, but, you know, somewhere way down towards the bottom of my proof, I'm going to have concluded this thing, and then I'll be able to use CP, right? Except, boy, that looks like one heck of a big thing to conclude if all I know is A to start out with. What can I do? What can I do? Oh dear, oh dear. I guess I need to have a subproof, right? I mean, I just can't get anywhere from here, right? Again, I'm going to color code this. It is not traditional to color code. Indentation is our notation. When you're doing your homework, you will indent. But let me show you this color coded. So what am I trying to do here? Well, I need to have this B implies A and B in order to get anywhere, right? So what I'm going to do is I'm going to try, and in my subproof, let's just assume as a premise that B, right? And then can we get to, the question is, can we get to A and B if I know B? And well, look at that. If I'm, now that I've assumed B, well, it makes things kind of easy, right? Because if I look at my rules, what do I need? I need A and B, but I can get A and B because I can use my conjunction rule, right? So now I could say A and B. I can conclude A and B based on lines 1, 2, and the conjunction rule, right? And check it out. I assumed B and I concluded A and B, which means that I could kind of outdent, right? And I can say, oh, wow, I did B implies A and B based on lines. What did we do? 2 to 3 and conditional proof, right? But having done that, so that discharged lines 2 to 3, but I've still got line 1 in there as a premise. So from line 1, I derived line 4, right? That means, presto changeo, nothing up my sleeves. I can say, oh, look at that. A implies B implies A and B based on lines 1. And now I really do say 1, 4 because the stuff in the middle was discharged and CP. Cool. Another example, I'm trying to prove something is a tautology. Check it out. Yet again, we've got that implies in there, which makes me think I'm going to end up, I'm going to use that whole conditional proof thing at the bottom. Okay, so what are we going to assume as my premise? I've got the left-hand side here. B implies C is my premise. And now the question is, where do I go from here? I mean, where am I trying to get to? I'm trying to get to this A and B implies A and C. What the heck, right? I'm just kind of thinking, how the heck do I get there, right? Is there any rule, any proof rule I could use that would get me there? No, I can't think of any. Well, let me try and do a subproof and see if maybe that helps. And again, color coding, but really it's all the indentation, right? We ignore the color coding, except it makes it easier to follow when the slides are on a video. So if I want to do a subproof, and I want to do a subproof where I am coming up with this thing, right? One way I could do it is proof by contradiction, right? I could assume the opposite of that. But you know what? Since there's an implications in there, I'm going to try and use conditional proof and assume that part as a premise and see if we can include the right hand side. So again, I'm going to assume A and B is a premise. Okay, so I'll say that's a premise, and again your book would say something like for A and B implies A and C, right? And even though I told you you don't really have to know the precedence rules for logic, you should know that implies has the lowest precedence. So this thing I've written really is the same as putting parentheses around these words. So the next question is, does this help us at all? If I have A and B, can I somehow get A and C? And I think we're in pretty good shape because now I get to call on my modus ponens again, right? Now it's all kind of coming together. I have A and B, right? I've got an and in a premise. What do we always do when we have an and in a premise? Well, we pull it apart. So I've got A based on line 2 and simplification, and I've got B based on line 2 and simplification. And now look it out, check it out. Modus ponens comes along because I've got my B here. B implies C, right? So I might as well use modus ponens. I could, of course, erase this later, but I don't think I'll have to. So that is based on line 1. B implies C, and line 4, and modus ponens. Okay, and now I take a step back and say, where the heck was I trying to get to? I was trying to do a from A and B, derive A and C. Aha, well, I just need to get A and C and check it out. I can do that now using the conjunction rule, right? I could say A and C based on lines 3 and 5 and the conjunction rule. And now I have indeed started with A and B, concluded A and C, so now I can outdent and say A and B implies A and C, and that is based on lines 2 through 6, not 2 comma 6, and the conditional proof rule, right? And now look, line 1 is where I wanted to get from, line 7 is where I wanted to get to, so I'm done. Your book would just write QED here. I'm going to write out the whole thing. B implies C implies A and B implies A and C, and that is by lines. Now let's see who's in here. It's not lines 2 through 6 because they've been discharged, so it's just line 1, line 7, and conditional proof. And now we write QED. Okay, one last example. I want to prove that this is a tautology. Again, we've got, sorry, making you seasick, I hope not. We've got this implication in here, so if we assume this and conclude that, we're in good shape. So let's start with our premise is this whole thing on the left, A or B implies C and D. All right, and that's our premise, and we're trying to get to this B implies D. Boy, that looks tricky. But, you know, I don't really see how I'm going to get to B implies D from this stuff. So I guess I'll start a subproof with B as a premise and see if I can get to D that way. Again, changing colors just so that you can tell I'm on a subproof, just to remind you if you just look at this picture statically later, you know, you freeze frame or something, but of course you really would know anyway just based on my indentation, right? So if I'm trying to, and I guess, I mean, I could assume the negation of this piece if I wanted to try and do an indirect proof, but I don't think that's going to work for me. So I'm going to assume B as my premise, and again, the book would write something like for B implies D, just telling you here's why I'm doing my subproof. Now let's see, if I know B, and again, you know, that thing in part 1, or line 1, I do have this implication. It would be nice if I could get A or B so I could get out this C and D piece from modus ponens. Ah, but I already have B, and if I already have B, then I can conclude A or B, right, based on line 2 and the addition rule. But now I feel like I'm on a roll because modus ponens is my favorite and I can use it, right? Because if I say I'm on line 4, notice I've got A or B here, A or B there, so I can conclude C and D. And of course, this was given to me as a homework problem, so probably whenever I can apply modus ponens I want to, so I will try. I can conclude C and D based on line 1 and 3 modus ponens. And again, think about it. Where am I trying to get to? I was trying to get to B implies D, right? I was trying to get this piece. Got C and D, woohoo. So simplification gets me there. Just say D based on line 4 and simplification. And look, I've now, from B, I concluded D. I derived D, right? So I can say, all right, we're back in our proof. I proved in my subproof that B implied D based on lines 2 through 5 and conditional proof. And now, you know what, everything just fell through beautifully. I started there, I went to there, that's what I was trying to do. Your book would just write QED on this line. I'm going to write it out. A or B implies C and D, and then that whole thing implies B implies D, and that is from what? It's just lines 1 and line 6 because the others were discharged, and CP, and then I get to write QED. So, you know, an awful lot of the problems that I'm going to be giving you are really going to kind of fall out through these kinds of examples. You know, it's sort of, it's hard at first. It really is hard at first, and I understand, to do these proofs. But hopefully maybe these examples helped you, and doing some more examples on your own for homework will help too.